Now we understand the valence electrons of different atoms. So we know that the valence electrons are the ones participate in the chemical reaction. So the chemical properties of elements, they are largely determined by the number of valence electrons they contain. So elements, they have the same number of valence electrons. In general, they have similar properties. For example, group 1A metals, lithium, potassium, sodium, they all have similar properties since they all have one valence electron. And electrons that are noble gases, they all have 8 valence electrons. They tend to be very, very stable. So elements that are close to noble gases on the periodic table, they are most active, such as group 1A, which is alkaline metals, and group 7A, they are halogens. And they are very close to noble gas because so they can attain the noble gas configuration by just gaining or losing one or two electrons. That's why they are very active. So the alkaline metals, halogens, for example, alkaline metals, they tend to lose one electron to form the exact same noble gas configuration, which make them very active. Now, if we look at the periodic table, we've talked about this table before. In group 1A, they tend to lose 1 electrons. Group 2A, they tend to lose 2 electrons. So when they lose those electrons, they will have exactly the same noble gas configuration. And then in group 6A and 7A, they tend to gain 1 or 2 electrons to form the same electron configuration with noble gas. Now, let's look at how we can predict the electron configuration of ions. So a cation forms when one or more electrons are removed from an electrons. So for example, if we look at sodium, sodium has the electron configuration of 1s2, 2s2, 2p6, 3s1. Now, we know that sodium plus 1, that means you lose 1 electrons, right? Since electron's negative charge, when you lose 1 electron, it becomes charged plus 1. So when you lose 1 electron, it will remove the electron from the outermost shell first, which is 3s. This is because it's furthest away from the nucleus, it has highest energy, it's mostly active. So you move that 1 electron and you form the electron configuration of 1s2, 2s2, 2p6. So this is the same electron configuration with neon, which makes the sodium plus ion is extremely stable. So an anion, they are negative charge, so they form when they gain 1 or more electrons from the parent atom. So now, when you add the electrons to form an anion, we just follow the Aufbauer principle. So for example, phosphorus has 15 electrons. It has electron configuration of 1s2, 2s2, 2p6, 3s2, 3p3. So when form an ion, it tends to gain 3 electrons. So now the 3 electrons are being added to 3p orbital because we know that a p set of subshell can fit 6 electrons max. So you can accept 3 electrons right there, and it has 1s2, 2s2, 2p6, 3s2, 3p6. And this is the electron configuration of phosphorus 3-, which is exactly the same with argon. We make it extremely stable as well. Now you can see here, so atoms, they tend to gain or lose electrons to form a more stable electron configuration, similar to the noble gas.